So now we're going to look at triangle congruencies. Today we're going to study CPCTC, SSS, and SAS. We will talk about each one of those and what those letters represent in just a minute. So first thing we want to discuss is congruence. When we have two geometric figures with exactly the same shape and size, those are considered congruent. So exact same shape and size is congruent. So if you look at the diagram down in the middle, we have two congruent figures. We have figure ABCD and figure EFGH. Looking at those two congruent figures, we can go through each part or piece and talk about congruent pieces. So here we have AB, that's congruent to EF. And that's written over here in this congruency statement. And we could go around and discuss all the sides and what their corresponding side is. And then we can do the same thing with the angles. And those are all listed there for you. So corresponding parts, if we have triangles, which is what we're going to focus on in this unit, every triangle that has a congruent partner has 6 pairs of corresponding parts. You'll have 3 pairs of sides and 3 pairs of angles that are congruent. And if that happens, you can say that the two triangles are then congruent. So looking here at this example, we know that side AB of this triangle at the top is congruent to side DE of the triangle at the bottom. We know that side BC is congruent to side EF. Those are the top right-hand sides of your triangles, and then the bottoms are also congruent, DF and AC, and therefore, since we know that, we can move to the angles. So angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. All that just comes from our congruency statement and that diagram. So a congruency statement is written just like this. When you write a congruency statement, you must match all corresponding angles and sides. So when I write my congruency statement, we wrote A, B, C over here. We went from the 1 arc mark to the 2 arc mark to the 3, which means when we label this one, we have to go from 1 to 2 to 3. So D, E, F is the correct order on that second triangle. Moving on to CPCTC. CPCTC stands for corresponding parts of congruent triangles are congruent. So if we know two triangles are congruent, then we know that every pair of corresponding parts must also be congruent. On this slide, you'll see that we're asked to label all or list all the congruent angles and sides given this congruency statement down here. So without drawing a diagram, we can do this. So to do this, we're just going to start with the angle side, and I'm going to pick the first letter in my congruency statement. So on the left side, the first letter is J, so angle J would be congruent to the first letter in the second triangle, which is angle P. Then I'm going to go with the middle letter. I'm going to say angle K is congruent to angle Q. They're both the middle letters in our congruency statement. And then the last letter, angle L, is congruent to the last letter in the second congruency statement, which is angle R. Then we get to go through and we get to list the corresponding sides. So sides are more fun. You have to have 2 letters for a side. So the first side I would pick is the first 2 letters. So side JK is congruent to side PQ. So first 2 letters are congruent to first 2 letters. Then I would do the last 2 letters, so KL is congruent to QR, And then last but not least, you get to do the first letter with the last letter on both of them. So JL is congruent to PR. And that's my 3 pairs of corresponding sides. The last thing we were asked to do is write another valid congruency statement. So I'm going to start off with triangle. And then to write my congruency statement, I need to just mess up the order in which these letters are written. So I'm just going to read them backwards. So I'm going to go with L, K, J is congruent to triangle. And then when I read the second one, I have to read it backwards as well. So R, Q, P. And that would be another valid congruency statement. So here we're given triangle KPM is congruent to triangle AYC, and then we want to complete the following statements. So KM, if I look, first letter, last letter is AC. The second one, CY, this time we're at the second congruency statement. Again, I always tend to use these statements instead of the diagram. So CYMP. PK is middle first, so I want YA, middle first. Angle Y is in the middle, angle P is in the middle. Angle K is first, angle A is first. Angle ACY. So if I go from angle A to C to Y, I'm going to have to go from K to M to P. And then last but not least, I have to, write 2 different congruency statements. So I was given triangle MPK is congruent to triangle CYA. And then the last one, triangle YAC is congruent to triangle PKM. So next comes the question, do we need all 6 pairs congruent? So that's our 3 angles and our 3 sides. The answer to that is no. We're going to learn about triangle congruencies with SSS and SAS next. So SSS stands for side, side, side. If you know that there are 3 congruent sides on one triangle to 3 congruent sides on another triangle, then those 2 triangles must be therefore congruent. So for example, here we have 2 triangles. In this diagram, we have side AB marked congruent to side DE. We also have side BC marked congruent to side EF, and side AC marked congruent to DF. Since we have all 3 sides on one triangle marked congruent to all 3 sides on the second triangle, we can therefore conclude that the 2 triangles are congruent by side, side, side. So this comes into play when we start writing proofs. So here's a sample side, side, side proof. We're going to always start out our proofs with the given information. So this is a proof in a T-chart. We're starting with our given information on the left. We have PQ is congruent to ST. So in my diagram, I'm marking PQ congruent to ST. And the reason I know that is because it was given to me in the original problem. I also know that QR is congruent to RT. So I'm going to mark that in my diagram. And again, that's given information. Statement number 3, we have R as the midpoint of PS. That was given to us. So that came from our given line. That tells us that since R is the midpoint of PS, a midpoint creates 2 equal or congruent segments. So that tells us that PR is congruent to RS by the definition of a midpoint. And therefore, we know that these two triangles are congruent. We've proved that we have 3 pairs of congruent sides. So we can prove these two triangles congruent by side, side, side. Our next proof, again, we're starting off with the given information. So first thing we were given is that JL is congruent to MN. So I'm going to mark that in my diagram. Then we were told that K is the midpoint of JN and LM. That's given. Since K is the midpoint, I know that this line segment is broken up into 2 equal pieces. So KL and MK are congruent to each other by the definition of a midpoint. And similarly, since K is also the midpoint of JN, then KJ and NK are also congruent. Again, by the definition of a midpoint. And again, we've proven that all 3 sides of one triangle have a corresponding side on the second triangle. So these two triangles are congruent by side, side, side. Example number 3, we were given some information. Again, that always goes on the left side. So first thing we were given is AC is congruent to AD. That's given. I'm going to go ahead and mark that on my diagram. So if AC is congruent to AD, put my congruency marks. Then I have that CB is congruent to BD. And again, I'm going to mark that on my diagram. So that takes care of the information I was given. For my third line, I need to prove that I have another side congruent in this diagram. So when I look at the 2 triangles, they both share this same line. Well, if the line's being shared by both triangles, it has to be congruent to itself. So AB is congruent to AB, and we justify that by the reflexive property. I always tell my students to imagine that you're putting a mirror up against something. It's going to reflect the exact same image as the original. So therefore, we've proven that we have 3 sides of one triangle congruent to 3 sides of another triangle. So therefore, triangle ABC is congruent to triangle ABD. And our justification for that is going to be side, side, side. Now we're going to move on to included angles. The angle is going to have to be between 2 sides that we know information about. So when I look at this first triangle here on the left, the angle that's included is this angle right here because it's between this side and this side. So angle G is the included angle. If I look at the triangle in the middle, I know this side right here and this side right here, which means angle I must be the included angle. And last but not least, we know this side here on the top right, this side on the bottom, which means that angle H must be the included angle. Which leads us to the next postulate, which is the side angle side postulate. So here it's important we have 2 sides. If we know those 2 sides are congruent and the angle included between those 2 sides is congruent, then the 2 triangles must therefore be congruent. So looking at these 2 triangles, we know that side AB is congruent to side DE. It's marked in the diagram. We also know that angle A is congruent to angle D. And we know that side AC is congruent to side DF. Keep in mind that angle A and angle D is the included angle between those 2 sides, and therefore we can conclude that these 2 triangles are congruent. let's start off with another proof. So again, starting off with our given information. So I'm going to go ahead and mark that given information. So JM, oops, that's not JM. Sorry, don't mind this little one. So JM is congruent to NL, that's the left side and the right side. Then angle JMN is congruent to angle LNM. So these two angles are congruent. Statement number 3 tells me that MN is congruent to MN. That's talking about this line right here that's shared between the two triangles. That's because of the reflexive property. Remember, any segment is congruent to itself. So MN is congruent to MN. For a reason, we just say that it's the reflexive property. And now we have a side, an angle, and a side. The angle is included between those two sides, so the two triangles are congruent by side, angle, side. Moving to the next diagram, again, we're starting off with the given information. So we were given that AB is congruent to BC, and the BD bisects ABC. So our first two statements are just given. And then I'm going to go to my diagram and mark AB congruent to BC. If BD bisects angle ABC, that's this angle right here. Anytime we talk about an angle being bisected, it means it's being cut into half, which means it creates two equal angles. So line 3 tells us that ABD is congruent to CBD because of the definition of a midpoint. Oh, pardon me, definition of bisect, not midpoint. Sorry, we bisect angles, midpoints deal with lines and cutting them in half. Our reason for number 4, we have BD congruent to BD. That's talking about this center line here. It's congruent to itself by the reflexive property. And now we have two triangles marked congruent with two pairs of sides and one pair of angles. The angles included, which means they're congruent by side, angle, side. Question number 6, we're told that V is the midpoint of WZ and XY. So we're going to start out with that given information. With that given information, if V is the midpoint of WZ, then it must create two equal segments, WV and VZ. So by the definition of midpoint, those two segments must be congruent. Then for some reason, the creator of this problem went ahead and jumped to an angle. So here we're referring to the two angles right here and right here. There is a special relationship between those angles. Those two angles are congruent because they are what we call vertical angles. So anytime you have a pair of vertical angles, they're opposite of each other at an intersection. They are always going to be congruent. So that's how we can justify step number 3. Step number 4, we're told that XV is congruent to VY. We can justify that because V is the midpoint of that line segment. So now we have two congruent pairs of sides, one congruent pair of angles. The angles are included in the middle. So this is congruent by side, angle, side. And last but not least, a tricky question. So here they're giving us information that HI is congruent to GJ. That's this top and bottom here. Again, we know that because it's given to us. And we're also given that HI and GJ are parallel to one another. So if we have parallel lines, so this line, remember our little arrows denote parallel lines. Since these two lines are parallel to each other, we have a transversal that's, well, actually we have three transversals, but we're going to focus on this transversal here, cutting through these parallel lines. We're going to ignore the other two lines for just a second. We want to show that GJH, this angle here, is congruent to this angle here. So looking just at the two parallel lines in that one transversal I highlighted for us, those two angles are alternate interior angles. And we know from a previous lesson that alternate interior angles are always congruent. Line number 4 tends to be a student favorite. HJ is congruent to HJ. Again, if anything's congruent to itself, it's congruent by the reflexive property. And then last but not least, we have two congruent sides, two congruent pairs of sides, two congruent pairs of sides, and then that included angle leads us to side, angle, side as our justification that these two triangles are congruent.